All right, so this video is a step-by-step guide on how to build your own Lego card scanning robot as shown in my video that I posted on Reddit. All of the relevant files like the build instructions, 3D models, and part list can be accessed for free on my website at garrettfricke.com/cardbot. And once you're on this page, the first thing you may notice is an embedded 3D model of the Lego robot. I wanted the 3D model to be viewable from both desktop and mobile without downloading anything. So you can zoom, rotate, move, or pan around to get a better view of the model. So you don't need a 3D CAD software to view the 3D model. If you want to just reference this and build what you see, totally fine. Below that, we have a bunch of different downloadable files. The first link includes the build instructions in PDF format. So you can just click on that and it'll open it up so you can download it up here. I highly recommend referencing both this PDF as well as watching this video. And this just has the different technical drawings for the different parts of this build. So definitely a good reference to use while you're watching this video. And the second file is the entire CAD model packaged in the original SolidWorks format. I saved this using SolidWorks 2017, so you will only be able to open this part in assembly files with SolidWorks 2017 or newer. This is what you'll get. You'll get a zip file. It has all the part files and all the assemblies. This one right here, the cardbot parentheses fixed, that is the one you want to open. That is the main file. You just extract these to a folder, open this, and then you will have the SolidWorks file. And it should be able to find and reference all of the parts, no problem. The third link is other 3D formats. I realize that not everyone will have access to SolidWorks, or maybe they have other formats that they prefer. So if you click this and download this, you'll see that I have included Blender format. So this is a blend file, step file, and STL files. Both of these are really good generic 3D model formats. All of these available through the third link right there. And the fourth link is the adjustment rail. It's an STL file. There's only one file, but I put it as a zip file just because that's what my website is able to host. But you'll download that and you'll have the STL or 3D printable 3D model for this plastic component right there. And I'll talk more about that once we get to that part of the build, but that is available for free right there as well. And this last link is the acrylic frame components in vector file or DXF format. And those are just the sidewall and other acrylic components. And you can cut them on your own laser cutter if you have access to that, or you can use a service like Oshcut or SendCutSend. And I've included different files to accommodate for the varying thicknesses. If you're ordering your own material and you're using 2.4 millimeter thick acrylic like I did, then I have the files in there for that. If you're ordering through SendCutSend, they don't offer 2.4 millimeters, so I've included a 3 millimeter thickness version that you can use through SendCutSend, and that'll work just fine. And if you scroll down past that, you will find some useful links. Now, this will probably be different from what you're seeing on the screen now. Like I'll have SendCutSend and Oshcut on here as well. I'm just kind of gradually adding to this as I think of useful links that people can use. So I'll keep adding to this. It'll be different than what you're seeing right now. So I'll reference these links throughout the video. So if you hear me say the link is on the page, this is where it will be. All right, so this is the acrylic I'm using for the sidewalls. And I'll put a link in the description and on the website of where I bought this. They do sell acrylic at like Lowe's and Home Depot, but that is extruded acrylic. This specific acrylic is cast acrylic, and this cuts phenomenally well on lasers. I'm cutting this on my 40-watt laser. It's a little too large of a sheet to fit on there, so I've just marked off about where I want to cut this. And you can either score it with a X-Acto blade or a knife and then break it. The easiest, laziest way I found is just using one of these paper cutters. Just a couple times. Just take it on the edge of the table. And snap it. This plastic. But then you have a nice, clean, straight edge. So there you go. I'm cutting these pieces on my 40-watt laser cutter in my shop, and this is the 2.4 millimeter thick acrylic cutting at 4 millimeters per second at 80% power. But if you don't have your own laser cutter, you can likely find a makerspace nearby that has one you can use. If you search for your location plus makerspace, you'd be surprised at how many different community makerspaces there are, and some of them will likely have a laser cutter you can use. If you'd rather just order these parts, you can download the DXF files I have on the website and upload the 3mm version to a service like SendCutSend. Now, I'm not sponsored by them or any of the other services mentioned in this video. They're just a phenomenal service that I've used quite a lot. It's super easy and inexpensive to use. You just upload your file, select the material type, in this case, 3mm clear acrylic, and click order. And as of the time I'm recording, you can order all of the acrylic parts for this project through SendCutSend for about $45, and they usually take less than a week to arrive. All right, so whether you cut them yourself with a laser cutter or cut them by hand or order them from an online site like SendCutSend or Oshcut, you're going to end up with 5 pieces like this. You're going to have your 2 walls, you're going to have your rail support, and you're going to have your base pieces. Now, these can be a little tricky to glue into place. And what I found is one of the better ways to do this is to just take these base pieces and some masking tape or painter's tape and lay them out like this first. Tab the slot like that and just fold the tape up and that'll hold it in place there. You're just going to do the same on the other side. And the reason I'm using the tape is just because we want all of the pieces installed when we glue it, because it is possible to, if you try and glue these without all of the pieces in place, it may not be square. There you go. And when this is folded up, slide it right into place. And when it's where you want it, you just fold these over onto the side. And these will hold it mostly in place. So now it's actually together. So now we're going to glue up these bonds. I like using super glue. You could really use any super glue, but I like using cyanoacrylate with some sort of accelerator or activator. These are pretty cheap. There will be links to all of this on the build page. But all you do is you just apply a little bit of the cyanoacrylate, or CA glue as it's sometimes called, to where you want it to be, and you just hit it with a little bit of spray. All right, so now I'm going to start on the inside corner right here. I'm going to make sure that everything is nice and squared up. I'm going to take our CA glue. Just going to put a nice little bead right in there. You don't need a lot. There you go. We'll take our activator, hit that just with a little bit, and that'll cause this cyanoacrylate, this super glue, to cure in a matter of seconds instead of having to hold it there for a couple minutes. And so we can actually go ahead and start gluing up these other joints while this is curing. Now, any super glue will work for this. I don't recommend any sort of expanding glue. So Gorilla Glue is probably not going to be the greatest. I think they might have a super glue variant, but the normal Gorilla Glue that kind of expands, you're not going to want to use that. There you go. And when you get up to the top right here, so you could just put the bead on the outside, just like that. There you go. And now we can actually start taking the tape off, because this should be fully cured now. So we no longer need this tape to hold it together. The super glue and activator is doing its job, and now it is holding this all together. And this is pretty rigid already, but what I'm going to do, just to be sure, make sure it's extra durable, I'm just going to go back in all the places where the tape was covering. So the outside little connector right there, or the outside of that tapping slot right there, I'm just going to put an extra little bead, blast with some activator. Do some up here too. And again, you don't need a ton. Like this is already going to be super strong how it is. Yeah, there you go. And this is the base of your Lego robot. So all of the axles and everything will just bolt right through those holes right there. And this is going to provide a really strong, rigid support. I mean, if I try and like flex this apart and like try and actively break this, it's already rigid and it's been glued for about 2 minutes. So it'll be plenty strong for what we're using it for. So. All right, so the next component we're going to work on is the belt and wheel assembly. And if you haven't already, go ahead and download the PDF that I have, the build instructions. I'll have all of the different parts sectioned out with all the part numbers in there. So what you're going to start with is this wheel. And this is one of the few Lego pieces we do have to modify slightly, because what we want is we want it to be like this. And we're just going to wrap some electrical tape around the inside of this wheel to build up the inner diameter. And what we're after is these belts. We want this belt to sit just barely above the edge of that wheel. We don't want it to be sunk down inside the wheel, and we don't want it to be entirely on top of the wheel. So we want that distance right there between the top of the tape and the top of this plastic to be about half of the thickness of this rubber belt. Right about there. And that'll let the card contact just the rubber and not the plastic, so we don't have to worry about the cards ever coming in contact with the plastic. So depending on the wheels you're using, if you're using these exact ones, which for some reason I had a hard time sourcing these exact wheels that had kind of the like smaller bit on the inside. I don't know what set these are from, But depending on what you're using, the electrical tape may be wider than the inner diameter. And so what I do is I just roll out a length of this tape. I just took it on like the edge of a table or a shelf or something. Then take your X-Acto knife or your blade, and you're just gonna try as best as you can to just slice that in half. Yeah. And it doesn't have to be perfect. You're gonna wrap this thing a whole bunch, but you do need about 6 feet total, or 5.5 feet, I guess is closer, of electrical tape. So if you take 3 feet of tape and split it down the middle, that should be enough for one wheel. And then you're gonna have to do that for all 4 wheels. I just can't see because I'm off camera. I'm just cutting this off. And I have my 2 pieces of electrical tape. I'm just gonna let that fall right there. Scoot this over so you can see. And what I'm gonna do is I'm just gonna take an axle, push it through there. Then you want something to kind of like help you control this, just so you can rotate a little easier. So this I'm using just as a handle. And we're going to thread this on here. What we're going to do is we're going to start wrapping this up, but as we're wrapping it, because it's electrical tape, you can kind of stretch it a little bit. I find that stretching it kind of helps smooth out some of the imperfections, and it also just helps it grip tighter. We don't want this to start coming unraveled as we're using this, because this is going to undergo a lot of repeated forces, because this is our pulley for the belt. Yeah, so I'm just wrapping this up. And again, doesn't need to be perfect. It's the first half. We just take this other 3 feet that we have. And then we're going to check this to see how we're doing. And as luck would have it, just kind of nailed it on the first try. The first one I've actually successfully done that on, but that's what we want. If it's a little too high, all you do is just peel some back, trim it, and then flatten it again and just check it. And you're just going to keep checking until it's looking just like that. And you're going to do that with all 4 of these wheels. So you have a set of 4 that look just like this. All right, so now we get to actually start putting this together. And the way these components go together, we are going to start by threading this through this wall. So, you can see it. So the thinner diameter wheel is on the inside. And we're going to have bushing. Another bushing. I'm just going to keep pushing this through. And then, this is important, make sure you put the belt on before you do the next step, because it's kind of a pain to try and get it on after. So then you take this is a 3x7 53 degree bent piece and put it through the second round hole right there. Okay. Then we're going to just push this through some more. Another bushing. Whoops, the bushing's broken. Another bushing. And then you take your wheel and you have to kind of have to pivot it in there around this bushing. And then you'll be able to press the axle through the rest of the way. So it usually helps if you just have a little bit of the axle. Just a little bit of the axle exposed right there. And line it up, push it through. And again, make sure you put this belt on. And then you can push the axle all the way through, like that. So this is what you should have. It is going to wiggle a little bit. That's not super important. It's going to be fairly self-centering once we have it all put together. So you don't need to worry about that too much. So we're going to do the same thing over here. We're going to put axle through, and then the smaller diameter on the inside. Thread it through. Make sure you're passing it through these belts. And once you get it hooked on this belt, it's going to kind of apply some tension. So then it's going to be a little bit harder to press this axle through. And I had to switch to these black bushings. I ran out of gray ones. But they're the same piece. They're just in black plastic instead of gray. Bushings on like that. And then we're going to pass it through second to last hole. Just like that. And that will make sure that this is in tension. And it takes a lot of the pressure off of this acrylic side and puts it on this beam, which is what we want. So I'm going to keep pushing it through. We're going to do another 2 bushings. Take our last wheel, fit it right in here. You kind of have to pivot it. And this is one of the reasons why I like using acrylic or clear acrylic for this, because it lets you see what's going on inside, so you don't have to kind of like kind of feel around in the dark and try and figure out what you're doing. But pass the belt over like that. Make sure the belt is actually over both wheels like that. And then press the axle remainder of the way through. Be careful not to put too much pressure on the acrylic sheet, because you can snap it if you're trying to yard on it too hard. There we go. Okay. And there you go. That's our belt mechanism. And when you have it at this point, you can kind of wobble this back and forth and realize that it doesn't have a lot of tension on the acrylic sheet. Most of the tension is on this belt or on this beam, which is what we want. And then these belts just rotate pretty freely, and that will be our card picker, or part of the card picker. All right, and for this next part, we're going to assemble the wheels that actually grab the card from the belt system and pull it forward onto the tray. Sorry, these are two different colors. I don't have a lot of things to pick from, but these are the same piece. Just this one's black plastic, this one's gray plastic. They're the 56 by 26 balloon tires. You can see right there. And there are a couple ways to do this. Doesn't really make a difference which way. Just one is going to save you some bushings if you are like me and use these as spacers or compression limiters. So we're going to feed our, and actually before we thread this through, I want to show you how we can use straws as spacers. So we're going to do one bushing and then our wheel with the I guess spokes facing out. So you'll have the concave side facing towards the middle of the machine. And then this typically calls for, I think it's four normal size bushings and a half bushing. So 4.5 bushing lengths total. Then you have your other tire. Then you have one more bushing. And I recommend assembling this just because it's pretty easy before you install it in here, because then you could just lay it on top of the frame. You can kind of gauge the fit. So it should just sit right in between the walls. But if you don't want to use all of those bushings, you can just take the wheels off and take the outside bushings off, and then you're left with that. And you can just line this up next to your straw or tubing or something. And then you could just cut this. And then you have a nice length of tubing that you can use instead of these bushings. And again, if you have like a big tub like this of like hundreds of them, you don't need to do this. This is purely if you were trying to be sparing with the amount of bushings you're using. So you put this on like this. Install your straw, your exterior bushing, and then it fits the exact same. So I'm going to do this just to save some bushings. So this goes through this hole, just like that. Install this, install your straw. Actually, don't know which one I just cut for this, but there you go. Install a straw. And then you'll have to kind of do the same pivoting to get this on there. There you go. You can see I have that through the wheel now. But now I need to put one of these bushings in between that axle and the wall. All right, so this one can be a little bit of a pain to get on. So what you could do is I recommend getting some like tweezers or needle nose pliers if you have them. If you don't, you could just use a pair of scissors. Just hold it lightly. We're just gonna use the scissors, kind of wiggle it into place. Just like that. And then if we press from the bottom, boom. There we go. Now, we get to do basically that entire process again, but with these smaller wheels. Again, I recommend doing your fitment test because you may not be using the same kind of wheels that I am. There you go. This fits perfectly. It's the same spacing as the ones below. So it's just two normal size bearings and two normal size bushings and one half size bushing. And the important part with this is making sure that the center of these wheels lines up with the center of these wheels. But by having these perfectly in plane with one another, they won't bend the cards at all. So you want these in line with one another, which with these parts and this configuration, these end up being just perfectly in line with each other. They don't bend the cards hardly at all. So we're just going to do the same thing. I'm going to feed this through. Again, using this style of wheel, make sure that this little protrusion is on the outside, and that causes it to line up perfectly with the center line of this tire below it. And then I'm going to use the straws again. Again, this is just 4.5 of these, so it's just 4 of these and 1 of these is that length. But I'm doing this because it doesn't really matter. I'm just using it as a spacer. But if you don't want to use straw, you can totally use the bushings. And that's totally fine too. Feed this through. And this one's a little easier because the tire is a little easier to access the other side of. So we're just going to place this on the axle like that. And then you are going to have to push a little downward. You'll see how the tire is compressing for me to get that fit. These are not very rigid. So these have a lot of give and a lot of elasticity. So we can compress these a little bit, and that's what's going to create the frictional force needed to grab the cards and pull them forward. So just so you can see how this works, this card will be pulled by this belt. I'll move it forward at the same time that these are driving. And this is very gentle. Like it's not pulling on the card, it's not marking the card, it's not denting the card. It's just enough friction to create grip. All right, so this next part is pretty straightforward. If you happen to see the first video that I had posted of the version 3, you may have noticed this, which obviously is a little janky. It's kind of a little thrown together solution I had using aluminum C channel and a piece of 1-inch PVC or rubber coated PVC. I think it was just from like my scrap pile. So I couldn't actually find this piece of tubing online. So I don't know where I got this. It was just in my scrap pile. And I didn't want to just tell people, hey, find a piece of scrap that was like mine. So instead, I am replacing it with a 3D printed equivalent. And through testing, this works just fine. You just print it straight up like this. It prints just fine without any supports. And this is what's going to limit the cards passing through on the conveyor belt, because you need some sort of limiter that you can adjust. And that's why this has these rails. Now, These are called T-slot bolts. You'll see some hardware places will mislabel these as like T-nuts. Some call them like square head bolts or T-bolts. T-slot bolts are the best thing that I can, or the most reliable thing that you could search to find these. And again, link for these, you could just get these off Amazon. Surprisingly, MasterCard does not carry these. They carry a much beefier version of these, but they don't carry these. I don't know why, but yeah, it's not very expensive to just buy them off Amazon. So we're going to pass this through here. We're going to take this nut. These are just 5/16, 18 T-slot bolts and a 5/16, 18 hex nut. And these hex nuts you could just buy anywhere they sell nuts and bolts. The T-slot bolts probably have to buy online or something. But yeah, so we're just going to thread them through like that. And then you want there to be a good amount of slack, maybe like 2 or 3 threads worth of slack, because then you could just take this 3D printed part and this just slides in just right on top of those bolts. And you can just let it fall right on the belt, just like that. And we're just going to finger tight. So we're just going to tighten these bolts down. And finger tight is plenty. You don't need this to be super tight. Any tighter than this, like if you go get a wrench or something and crank down this, you're going to start cracking the acrylic, and we don't want that. So finger tight, more than plenty. It's not going to come loose, so you don't have to worry about that. And what this lets us do is this lets us adjust or fine tune the width. You don't really need to go this high. I just made it this tall to create a good support for cards resting against this surface. But yeah, what I do for this, and you'll want to adjust it more once it's fully together, but you'll feed a card through, and when it's about halfway through like that, push this down and then tighten. And then that will still allow this card to pass through freely, just like that. But it'll stop all of the cards on top of that bottom card. So you're creating a gap 1 card wide. So it physically cannot pull multiple cards through. However, one benefit to this being adjustable is if you are trying to feed sleeved cards through and you're finding that the gap is not wide enough to feed a sleeved card, you just loosen these, widen it just a hair, and then tighten it back up. And then it should feed sleeved cards through just fine. And I did make this design about 2 millimeters wider than version 3. And that was so, let me grab some sleeved cards real quick. There we go. Grab my Mizzix EDH deck. And that was because I wanted these to work with sleeved cards as well as non-sleeved cards. And we'll see when it's put together, or we'll see a little better when it's all put together. But it works just fine with these sleeved cards. You don't have to worry about unsleeving cards or anything of that sort. So from this point forward, I recommend just referencing the PDF, which includes step-by-step instructions for finishing the last bit of assembly. I'll be jumping ahead a little bit now to a completed assembly so I can give a brief explanation of what each of those parts does before we start our programming. So by now we should have finished up the last 10 pages of the PDF, which has all of these build instructions, and that would have walked us through building the card ramp assembly, what I'm calling the card jostler here on the back, assembling the gears on the side, and mounting the two motors. You may have noticed I had the 3D printed adjustment rail kind of out of order. I did that pretty much last. It doesn't matter if you assemble this 3D printed component in the order I did in the video or in the order I did in the PDF. So just to talk about what these different components do. The first one is the card ramp. The cards will feed through the belt and land on the card ramp, which will give the camera a chance to scan the card. And then this motor over here, once it recognizes that there's a card on top of this light sensor, will rotate this cam one full rotation, which will kick the card up and over this lip. And then the next card will fall into place and the cycle just repeats itself. And that's where you have your continuous flow of cards going through the robot. The gear assembly lets this motor drive the belts and the wheels simultaneously. This card jostler in the back, it's kind of a little bit of a minimalist design, but when you load cards in here, the cards are going to rest on this back beam that's angled up. So they're not going to be laying completely flat. And then I have an angled piece right here that's in contact with this cam that is rotating in time with this belt. And what this will do is this beam will just sway slightly as this rotates, and it'll cause the beam holding the cards to just jostle up and down periodically. And that'll keep cards from getting stuck together. And make sure that you have a very consistent feed rate into the machine. Also, it's worth mentioning, I did not include a way to mount this left motor. I'm still kind of deciding what I want to do with this. And I'm still kind of playing around with how I want to mount these. So the easiest way, if you look back at the version 3 that I posted, I just had a beam connected to a Lego build plate that this was sitting on. And that's the easiest way to support it. However, if you just leave this suspended like this and not mounted to anything or not supported by anything, it'll still work just fine, as you'll see in the next clips that I have.